Okay, this is my second attempt at this video because the first time I did not read the directions. My bad. So we've already talked about squares, a little bit. We've already talked about rectangles and rhombi. Today we're going to talk about a square, which is a special type of rectangle that's also a rhombus. So you can see that on our family tree for quadrilaterals, the rhombi and rectangles converge into the squares. A square is special. It is a parallelogram, it's a rectangle, and it's a rhombus, so it has the properties of all three of those things. Okay, so we are going to show that the diagonals of this square are congruent, perpendicular bisectors of each other. So to show that the diagonals are congruent, we're going to use the Pythagorean theorem. Okay, so that's a squared plus b squared equals c squared. To show that they are perpendicular, we're going to use slope. So to be perpendicular, our diagonals must be opposite. Reciprocals. And if they bisect each other, they should have the same midpoint. So we're going to use midpoint to show the bit about the bisectors. Okay, so let's start with the Pythagorean theorem. When I didn't read this the first time, I did the Pythagorean theorem for all of the sides instead of the diagonals. Whoops. All right, that'll teach me not to read the directions. Okay, so here is a diagonal. And what I want to do is make a right triangle where this is our C, that's our hypotenuse, and here my little legs are the A and the B. Okay, so my first leg, my A is 1 squared plus B is 1, 2, 3, 4, 5, 6, 7 squared. Did I do that right? Yes. Okay, and that should give us our hypotenuse squared. So 1 squared is 1, 7 squared is 49. So C squared. Now I have to add the 1 and the 49 together. I get 50 is C squared. And now I don't want C squared, I really just want C, so I'm going to take the square root. Now this is an equation, and there are two numbers, one positive and one negative, that when I square them, I get 50. So in geometry, though, we only care about the positive one because it's supposed to be our length, and lengths and distances are positive. So I want the positive square root of 50. Now, 50 has a perfect square factor, which is 25. So this is root 25 times root 2. And we know the square root of 25 is 5. So that's 5 root 2 for our C. Okay, so let's check what we've got for our second diagonal. Second diagonal is going to go right here. Okay, and let's make a little right triangle for him. Okay, so I see an A of 1 and a B of 1, 2, 3, 4, 5, 6, 7. So if these triangles have the same legs, like by side angle side, they're congruent, so I can say that the hypotenuses are congruent. So here's my side, here's my angle, here's my side. That matches exactly the other one I had for my other diagonal. So I know that this diagonal and that diagonal are congruent. So I can say, what is that? F, H, is congruent to EG. I'm not going to mark it on the picture right now because where I would put the tick marks is over here or here. And that just looks confusing, like only one of those little baby segments are congruent. So I'm not going to put tick marks right now. Okay. Now we have to show that the diagonals are opposite reciprocals. So let's find their slopes. The slope of FH is down 7, right 1. M for FH is down 7, right 1, rise over run, so that's negative 7. Okay, the slope for EG is up 1, right 7. Up 1, right 7. So these are opposite reciprocals. So we know that EG is perpendicular to FH. Okay, the last thing we have to do is show that they are bisectors of each other. So for that, we're going to need the midpoint. I'm going to erase everything on my picture. I wish they would have given us like 3 pictures. That's what I'll do next year, is change this to 3 pictures. Okay, so the midpoint for each of these, what I have to do is average the x's together and average the y's together to find the x and y values that are halfway in between. So for FH, this is our midpoints. For FH, I'm going to take negative 1 plus 0 over 2 and 3 plus negative 4 over 2. This is for FH. Okay, so negative 1 plus 0, that's negative 1. And divide that by 2, I get negative 1/2. 3 plus negative 4 is negative 1. Divide that by 2, I get negative 1/2. This one is for FH. Okay, let's do GE. Or EG, whatever. Okay, so for EG, I have negative 4 plus 3 divided by 2 and negative 1 plus, negative 1 plus 0 divided by 2. So negative 4 plus 3, that's negative 1 over 2. And negative 1 plus 0 is negative 1 over 2. This is for EG. So these two diagonals are intersecting each other at their midpoints, so they bisect each other. So I can say boop, 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 like that. Okay, that was a lot. I don't know. Okay, here we go. We have to show that the vertices of this square are negative 5, 4. T is at 0, 2. V is at 6, negative 3. Really? And W is at 1, negative 9. Did I mess this up? Okay, let me fix my picture. I'm having a brain fart right now. I'm too close to. Okay, wouldn't you know it was the very first one I did. I thought I read -5 +4. It's -4. So I put S in the wrong spot. We have to move S down here. Now it looks like a square. Okay, cool. So I'm going to connect my sides. Pew, 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 pew. Okay, so I have to show that the diagonals of square STVW are congruent perpendicular bisectors of each other. Okay, I feel like we just did that, so we're not going to do it again. Okay, determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. So given that EB is congruent to BG and FB is congruent to BH, triangle EBF is congruent to triangle EBH. EBF is congruent to EBH. Okay, so I'm still thinking about this one, but I'm going to think out loud instead of like by myself. Okay, so angle E is congruent to angle E. B is congruent to angle B. And F is congruent to angle H. Okay, so what I'm thinking right now is that for sure this thing is a rhombus, okay, because we've got the diagonals bisecting each other. Okay, what we don't know is if this rhombus is also a rectangle. So I'm going to see if those congruent statements are still true if I draw it obviously as like a rhombus that's not a square. Okay, so if it's just a rhombus and not a square, the diagonals will still bisect each other. These. Okay, guys, I misread this a little bit. So it says that EB is congruent to BG. I got that part right. Okay, and then it says that FB. Oh, see, I skipped over this one. Okay, so that was my problem. I got those marked correctly, and then what I forgot was that EG, this one, is congruent to that one. Okay, so there are a couple of things that we need to talk about. First, our diagonals bisect each other. So that's how we know it's a parallelogram. So diagonals bisect each other. So we know it's a parallelogram. We can use the little symbol. Okay, next, the diagonals are congruent. That's this part that I skipped over. This part right here the diagonals are congruent. You know how I said that we could tell it was a rhombus, but we didn't know if it was a rectangle? It's because I skipped part of the problem. So the diagonals are congruent, so we know it's a rectangle. Okay, now we just have to show that it's a rhombus. So when it tells us this bit of information about these two triangles being congruent, this one and this one, we know then that these two sides are congruent. Okay, and if consecutive sides are congruent, then it has to be a rhombus. Okay, so if it's a parallelogram, a rectangle, and a rhombus, it's a square. So this is valid. I thought for a second it wasn't valid, but that's because I skipped over part of the problem. So awesome. Good start to the day. Okay. You have to use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. So we have to assign it all of the names that apply. Okay. So P is at -1, 4. Q is at 2, 6. R is at 4, 3. S is at 1, 1. 1, 1. Why do I suck at graphing today? 4, 4, 3 is up here, guys. That's why I suck at graphing today. I cannot do positive and negatives to save my life. Okay, it's fine. We'll be fine. All right. We have to use the diagonals. So let's start with the slopes. So the slope for PR is down 1, right 1, 2, 3, 4, 5. Yeah. Okay, the slope for QS is up 5, right 1. So 5. So these are opposite reciprocals. So if they are perpendicular, if the diagonals are perpendicular, then we know that this is a rhombus. So it's a rhombus. Okay, if this is also a rectangle, then it's a square. So to see if it's a rectangle, we have to say, if we have to see that the diagonals are congruent. So let's draw in the other diagonal, and we can use our a squared plus b squared equals c squared. The Pythagorean theorem. So I'm going to start with PR, the pink one. So for PR, if I draw a little right triangle, I have a side of 1 and a side of 1, 2, 3, 4, 5. 1 squared plus 5 squared is the C, my length of diagonal squared. So 1 squared is 1, 5 squared is 25, so my C squared is 26. Square root both sides. Two numbers, values make this true, but I'm in geometry looking for a length, so I want the positive one. So I want the positive square root of 26 for my C. 26 has no perfect square factors, so that's already simplified. Now I have to do the same thing for my other diagonal. Make a little right triangle. There he is. Okay, so I'm going, one side is 1 and the other side is 1, 2, 3, 4, 5. Well, guys, that's the same math. So if I do 1 squared plus 5 squared equals C squared, I'm going to end up doing the same exact steps, and I'm going to get root 26 for this other C also. So if my diagonals are congruent, which they are, diagonals, oops, that's big. Diagonals are congruent. So this is a rectangle. Now, if it is both a rectangle and a rhombus, we can say that it is a square. So it's a rhombus, it's a square, it's a rectangle. Okay, I was just looking ahead at the next two examples. They're like these. They're the same direction. So we're not going to do all of these. We're just going to do one more and then we're going to call it. Okay, so -5, 6 is my W. X is at -1, 8. Y is at 2, 2. And Z is at -2, 0. Guys, we just have to do the same thing. So to see if this is a rhombus, we have to find the slopes of our diagonals and see if they're opposite reciprocals. So my first diagonal is here. That one is going up 1, 2, 3, 4, 5. Oh my gosh. That looks like up 8 and right 1. So my slope for ZX is 8. Now I have to find my slope for WY. So that looks like it's going down 1, 2, 3, 4, and right 1, no, 1, 2, 3, 4, 5, 6, 7. -5, yep, 7. Okay, so this one is 4/7. So those are obviously not opposite reciprocals, so this is not a rhombus. Okay, if it's not a rhombus, it can't be a square. So we're going to say not a square. Okay, let's see if it's a rectangle. If it's a rectangle, our diagonals will be congruent. So we just have to find their lengths. So I'm going to make my little right triangle so I can use my Pythagorean theorem. This right triangle has a length of 1 for one leg and 8 for the other leg. So I'm going to do 1 squared plus 8 squared equals my c squared. 1 squared is 1. 8 squared is 64. So my c squared is 65. I don't know why I wrote 2. Okay, I'm going to take the square root. Square root has 2 solutions. I want the positive one. 65 has no perfect square factors, so my c is just root 65. That's for that pink one I just did. Now let's do the other one. So this side is 1, 2, 3, 4, and this side is 1, 2, 3, 4, 5, 6, 7. Okay, so 4 squared plus 7 squared equals c squared. I feel like I need a calculator. Okay, 4 squared is 16, and 7 squared is 49. I feel like that is 65, but I'm not doing very well this morning, so I'm just going to check. Okay, it is 65. So 65 is our c squared. Square root, square root. We have 2 solutions. We just want the positive one. And we get c is root 65. So our diagonals are congruent. This is a rectangle. Diagonals. This is a rectangle. It is not a square. It is not a rhombus, but it is a rectangle. Okay, we're done.